is an unified modeling language. And in this video lecture, we are going to cover 5 topics, that is, what is UML, history of UML, stages of OMT, that is object modeling techniques, and fourth one is models in OOM, that is object oriented modeling, and fifth one is inheritance and its types. So what is UML? As I have told, UML is an unified modeling language. So UML is a basic programming language in the field of software and it is a standard way to visualize and design system. And this UML has been evolved in late 1990s and has its roots in the early 1990s and late 1980s. And this UML has been evolved from Booch process or Booch algorithm, and it is a combination of OMT, that is object modeling techniques, and it is also a combination of OOSC, that is object oriented software engineering. And from this combination of these four, it is programmed into one language, that is UML. So UML is a combination of 4 languages, that is UML, OMT, OOM and OOSC. Sorry, 3 languages. We have stages of OMT. There are 4 stages in OMT, that is analysis phase, system design phase, object design phase, and implementation phase. So what is analysis phase? Analysis phase, it starts from problem statements, which an analyst give and problem statements regarding system, which system we want to design, and this problem statement should be concise and precise. And the next state is system design phase, and this system design phase, in this the system designer fills within overall architecture of the design, which contains an overall architecture of design, system design, in which should have in the program. And the third phase is object design phase. In this it contains the all implementation details of the model. In this phase, the object designer keeps the full implementation details of the program. And last one is implementation. Implementation is in a relationship between object and classes, which is translated into a programming language. This during implementation, the designer should follow good software engineering properties. Should for the program should be concise and flexible. Stages of OMT. There are 4 stages in OMT. That is, first one is analysis phase, second one is system design phase, third one is object design phase, and fourth one is implementation phase. In analysis phase, it starts from the problem statements, in which the analyst analyzes the problems in the real world, which finds out the problem statements in which the programmer needs to design a program and or model. This problem statement should be concise and precise. Second phase is system design phase. The system designer deals with the high level architecture of the overall architecture of the programming model. And third phase is object design phase, in which it contains the overall implementation details in the model. And fourth stage is implementation. It is the relationship between object and classes translated into one programming language. And and this implementation should be flexible and extensive. For that, the software developer should have to practice good engineering practices. Topic in this lecture is models in OOM, that is object oriented modeling. So what is a model? Model is an abstraction of something for the purpose of understanding it before building it. Means we have three models in OOM, that is object oriented modeling. There are three models: are object model, dynamic model, and functional model. The object model describes object in the system and their relationship. The object model consists of object diagram, and the object diagram consists graph of nodes of graph of arcs and object and classes. The next model is dynamic model. The dynamic model deals with describes the interaction between the objects, and the dynamic model consists of state diagram. The state diagram deals with is a graph whose nodes are state diagram is a graph whose nodes are states and arcs. And the last model is functional model. It is the data transformation in the system. The functional model deals with the DFD, that is data flow diagram. And in this DFD it is consists of processes and arcs. The topic of this video lecture is that is the fifth topic, that is inheritance. So what is inheritance? Inheritance is the property or type in which we inherited the properties of superclass, that is the parent class, to the subclass, that is child class. And this inheritance consists of 5 types: single inheritance, multiple inheritance, and multi-level inheritance, hierarchical inheritance, and hybrid inheritance. First one is single inheritance, which have one superclass and one subclass. That is like this. A, suppose this one is in one superclass, and this B class, that is subclass. And in this, the properties of A is inherited to B, and this is known as single inheritance. And the second one is multiple inheritance, in which we have 2 or more superclass and only one child class. Let's see. This A and B, suppose these both are superclass, and this C is an subclass. In this, the properties of A and B are inherited to C. That is, the C is combination of A and B. And the third one is multi-level inheritance, in which we have one or more level, in which the properties of one level is transferred or inherited to second level or in the third level, like this. Let's see. In this, suppose A is one parent class, and this properties of A is inherited to B, and the properties of B is inherited to C. This is a multi-level inheritance class, which have in this C will have the properties of A as well as B. And the next one is hierarchical inheritance, in which we have one parent class and many subclasses. Sorry, one super class and many subclasses. This is the sign of generalization. In which, in this hierarchical inheritance, the properties of A is inherited to B, C as well as D. And the next one is hybrid inheritance. Let's see. We'll draw over here. In this hybrid inheritance, it is in combination of multiple and hierarchical are inherited to B and C. In this, the properties of B and as well as A added to D, and the properties of C as well as D and A as well as C added to D. And this is the combination of multi-level and hierarchical inheritance.